All right, so in chapter 6, we're going to take a look at what they call similar figures and similar triangles. Before we get into that, a couple things we're going to have to review. First one is the idea of simplifying a radical. When we look at simplifying a radical here, right, this is where we look for a perfect square that goes evenly into it. If you remember from earlier this year, perfect squares, those are numbers like 4, 9, 16, 25. Numbers you know the square root of. So you want to pick the biggest perfect square that goes into 48. The biggest perfect square that goes into 48 evenly is 16. So we break it up into the square root of 16 times what? 16 times what is 48? And that answer is 3. So it's the square root of 16 times the square root of 3. We picked 16 because we knew the square root of it. The square root of 16 is 4. So when they want us to reduce that radical, it is 4 times the square root of 3 then. Right? Reducing your radical is something we're going to have to be able to work with going forward here. Now, once again, as I said, we're going to review a couple things along the way. When we are working with similar figures, right, we're going to talk about the ratio between them. All a ratio is it is a comparison of two different things. So if A and B are two numbers or quantities, and B does not equal 0, the way we write a ratio is we can write it as A over B, we can write it as A with that colon B, or we can actually write it out as in the words A to B. So for example, we can take a look at a rectangle, and we can compare the length to the width. Or some people may want to term it the base to the height. Right? Or if you wanted to write it as a fraction, we could be looking at 6 feet over 4 feet. Or 6 feet to 4 feet, depending on which way you want to write it. And then just like all fractions, we're going to reduce it. First off, make sure that your units will cancel each other out. Feet will cancel with feet. And then we just reduce that 6 to 4, or 6 over 4. And we get 3 to 2. Or if you write it as a fraction, 3 over 2. That is what a ratio is. So let's look at example 1 then. In example 1, it says simplify the following ratios. So we're looking at this ratio, 76 centimeters to 8 centimeters. Right? 76 centimeters to 8 centimeters. My units cancel each other. And 76 over 8 reduces to 19 to 2. Now, in your second one here, please note your units are not the same. So we need to convert those feet into inches. 4 feet is equal to 48 inches. My 24 inches stays the same. Now my units can cancel each other out. Inches cancel with inches, and I'm left with 48 over 24, which reduces to 2 over 1. And typically, you will leave that 1 there since a ratio is technically a comparison of two things. All right, let's take a look at example 2. It says Jim is painting barn doors. He knows that the perimeter of the barn doors is 64 feet. It says the ratio of the length to the height is 3 to 5. It says find the area of the barn doors. Now, in these problems, it says the ratio is 3 to 5. Remember, that is a reduced value. To find perimeter, we are going to add up all the sides. Well, if I add up all my sides, I have my 3, I have my 5. Since it's a rectangle, we know that this side is also 3, and this side is also 5. They tell us that the perimeter is 64. When I look at the values that are here, 3 plus 5 plus 3 plus 5, which is how we would find perimeter, it does not equal 64. However, since a ratio can be reduced, what they are saying is that it is some multiple of this that is going to get you to 64. So we're going to call them 3x, 5x, 3x, and 5x. It is some multiple of that ratio that will work. When I combine all of my x's together, we get 16x equals 64. And then when we divide, we get x to equal 4. That tells me that that multiplier, what I need to multiply my ratio by, is 4. So on the bottom, we get 12. And on the right, we get 20. On the top, we have 12. On the left, we have 20. 12 plus 20 plus 12 plus 20. Now that does equal 64. To answer our question then, find the area of our doors. Area of a rectangle is base times height, so it is 12 times 20. 12 times 20 is 240, and then we just look at our units. Everything is in feet, so my area is 240 feet squared. Take a look at our next one then. Now it tells us the area of that rectangular garden is 108 square feet. It says the ratio of length to width is 4:3. It says find the length and the width of the fence needed to enclose the garden. Right? Area is 108 feet squared. Well, right now when I look at this, 4 times 3 does not equal 108. They are, though, saying that some multiple of that will. So we're saying that it is 4x times 3x. 4x times 3x must equal 108. 4x times 3x is 12x squared. To solve your equation, first thing we have to do is divide by 12. We have x squared equals 9. And then we take the square root of each side. That tells us that our multiplier is going to be 3. So 4 times 3 gives me 12 on the bottom. 3 times 3 gives me 9 on the right. 12 times 9 does equal 108. So what is the length and width of the fence? It is 12 feet and 9 feet. Right, looking at example 3. Example 3 is very similar with working with these ratios. The difference being is now it's in what they call an extended ratio. All an extended ratio is, it's going to be a measurement or a ratio that shows 3 different things. So it says the measures of the angles in triangle BCD are in the extended ratio of 2:3:4. It says find the measures of those angles. Well, the ratio 2:3:4, the only thing we know about the angles of a triangle is they have to add to 180. Well, 2 plus 3 plus 4, which is the ratio we're looking at, does not equal 180. However, some multiple of it will. So I multiply the 2 by x, the 3 by x, and the 4 by x. When I add these together, we get 9x equals 180. So when we divide, we find x to be 20. That is my multiplier. 2 times 20 is 40. 3 times 20 is 60. 4 times 20 is 80. So there are my 3 measurements of my angles then. Very similar in B then. B says now my extended ratio is 10:6:2. Well, once again, 10 plus 6 plus 2 does not equal 180. They are saying some multiple of it will, though. So it is 10x. It is 6x. It is 2x as the measurements of your three angles. So 10x plus 6x plus 2x is what has to equal 180. Combine your like terms. Oops. We get 18x equals 180. So divide, and our multiplier will be 10. So the three angle measurements will be 100 degrees, 60 degrees, and 20 degrees. All right, brings us to our second part here. Second part deals with what's called a proportion. Right? And you've dealt with proportions before. We've solved proportions before. All a proportion is, it's an equation that states that two ratios are equal. Right? You use them in a scenario like this, where we go to figure out what x is. Now, most people look at this and say, okay, 2 to 6, we're multiplying by 3, so take the 5 to the x, so we're going to have to multiply that by 3. And yes, that works perfectly fine here. The problem is, as soon as I go to change some of my values that are here, if all of a sudden I make this a 2x plus 1, and I make this a 2x, now all of a sudden you can't set it up the same way. You can't look at it and just figure it out just by looking at it. We're actually going to have to set up that proportion. Right? 2x compares to 6 the same way 5 will have to compare to 2x plus 1. And then we'll go through, we'll cross multiply, and we'll get our answers. That process of cross multiplying is what's known as taking our means and our extremes. The means essentially are the bottom left and the top right of your proportion. Your extremes are the top left and the bottom right. Right? And actually, as we'll learn in 6.2, those terms are actually interchangeable, because we're going to go through and be doing some things with our proportions in 6.2. So if we look at example 4 then, to solve our proportion, we are going to cross multiply. 4 times x is 4x. 3 times 16 is 48. So there's our equation to solve. We divide both sides by 4, and we get x to equal 12. Right? Setting up your proportion then. It says Christy wants to find the total number of rows of boards that make up 24 lanes at a bowling alley. She knows there are 117 rows and 3 lanes. It says find the total number of rows of boards that make up the 24 lanes. Right, so when we're looking to do this, you need to find something to compare. We have lanes, we have rows, we have lanes. So find a thing to compare. You want to compare lanes to rows? That's fine. You want to compare lanes to lanes? That's fine. If I compare 117 rows, for example, there are 3 lanes. So right now I'm comparing rows to lanes. Then in my next one, I have to compare rows to lanes again. If I do 117 rows over 3 lanes, I have rows on top, lanes on the bottom. There are 24 lanes in our whole place. My rows then is my x. That's what I'm trying to figure out. How many total rows are there? So there's our equation to solve. 3 times x is 3x. 117 times 24 gives us 2,808. To solve, we divide by 3, and we get x to equal 936. That was 936 rows. Last thing in 6.1 then is what's known as taking the geometric mean. take the geometric mean of two numbers. Right? Whoops. Take the geometric mean of two numbers. It says it's the value of two positive numbers, a and b, that satisfy our following proportion. So if I wanted to do the geometric mean, for example, of 4 and 5, what that means is I am going to have 4 over x and x over 5. And then we will cross multiply. X times x is x squared. 4 times 5 is 20. Now, to do a geometric mean, they are going to want it in a reduced radical, meaning it needs to be in exact form. This is where we go and we take the square root of each side, and this is why we reviewed that in the opener. When we take the square root of each side, we have x equals the square root of 20. I need this as a reduced radical, so we are looking for a perfect square that goes into it. Perfect squares are numbers like 4, 9, 16, 25. Right? The perfect square that goes into it is 4. So the square root of 4 times what? 4 times what is 20? And that would be 5. We picked 4 because we know the square root of it. The square root of 4 is 2. All right, so taking a look at example 6 then. Determining our geometric mean. So to set up our proportion, it's 16 over x equals x over 48. Cross multiply, we have x squared equals 768. And then we take the square root of each side. So x equals that square root of 768. So we need a perfect square that goes into 768. The perfect square we are going to use then is we can start with 64 if we wanted. We can do 64 times 12. Square root of 64 is 8. So we have x equals 8 square roots of 12. Now, 12 in itself can still be reduced. A perfect square that goes into 12 is 4. And it's 4 times 3. The square root of 4 is 2. So we have x equals 8 times 2 times that square root of 3. And 8 times 2 is 16. So my answer is 16 times the square root of 3. Taking a look at b then, we have 12 over x. We have x over 48. Cross multiply, x squared equals 12 times 48. It's 576. And then we take the square root of each side. So once again, we are looking for a perfect square that goes into this time 576. Well, if you notice, the square root of 576. Oh, why did I put 48? I'm sorry. It should be 12 and 27. That is my mistake there. So I got x squared equals 12 times 27. It's 324. The square root of 324 is actually a whole number. It is 18. All right, taking a look at C then. 18 over x. X over 54. Cross multiply. X times x is x squared. 18 times 54 is 972. Then we take the square root of each side. Square root of 972 is not a whole number, so we do have to reduce this. So to find a perfect square that goes into it, my biggest perfect square that goes into it is 324. And it's 324 times 3. The square root of 324 Well, that didn't work. Let me put that back up there for you. So we had 18 over x equal to x over 54. Cross multiply, we got x squared equals 324. And then we took the square root of each side. Oh, nope, not 324. My God. 972. Take the square root of each side. We found our perfect square to go into it was going to be 324. It was 324 times 3. And the square root of 324 we said was 18. Last one then. We had 16 over x and x over 18. Cross multiply, x squared equals 16 times 18 is 288. Then we take the square root of each side. Looking for a perfect square that goes into 288. And that square root would be 144. Or that perfect square would be 144. 144 times what? That is 2. So we get x equals the square root of 144 is 12. Right? And here's your homework for tonight. Now I put that page 921 on here. I put this page 921 on here because that is your conversion chart in your book. If you need to look up any conversions, that is the page you can look at. Right? If you have any questions, please email me.